Okay. First of all, with online classes, it's usually not the best thing to do personally. In today's class, we will not dive too much deeper into different technical things because it is online. And hopefully, when we resume physical classes, then we can review these topics. We can come back on these topics and then discuss them further. Now, I have posted a link in your Google Classroom, and the link is to the Google Sheet where you have to just fill. It's just simple information, your ID, your name, and then your email, your IUT email. So that I will try to add you to an AWS classroom. So I'll try to do that by this weekend, and I have to have your email and ID. So you have to fill the form by Friday latest. Should be Friday. And regarding the topic itself, as I've said, since it is online and there are some technical things that will be taught, I don't want to go too much into the theoretical or explanation because next week will also, not next week, but the next physical class will also come back to these things and discuss again them in details. Now, I just want to have a short review of what we did last class. So in the first chapter, we introduced cloud computing. I gave you the definition of cloud computing, and I mentioned that the definition itself is not a word for word thing that you have to memorize, but you have to convey some certain important characteristics of cloud computing. How the demand access of cloud computing, the resources that you can use in cloud computing, the network, storage, and everything, and also mention how it is accessed, meaning over the internet and pay-as-you-go basis. So if you convey these different characteristics and measures of cloud computing, then in that case, there can be a fine definition for cloud computing. Now, another thing that we discussed were the different characteristics of cloud. And we explained the different scalability and producibility of cloud and some of the other things that we mentioned. And another concept that we also explained from previous class was the concept of the service modules of cloud computing. And we discussed mainly 3 service modules. Now, those are not the only 3 service modules because over time there are a lot of them. Now you have things like data as a service, you have function as a service, you have a lot of different services. But the 3 main ones are always the one that we discuss in class, which is software as a service, platform as a service, and infrastructure as a service. And this is just a summary of what we did from previous lecture. And as I've said, you have to be able to understand this concept and these services properly for you to actually claim that you understand cloud computing very well. So we discussed about in terms of software as a service, we mentioned the examples of software that you use. Let's say, for example, you have Google Drive, you have maybe Google Sheet or email or something. So whenever you're using those applications, those software that is developed by somebody and just provided, in that case, it is considered a software as a service because the services you are using on the cloud is only the software. So you are not in control of anything. Everything was already designed and you are just using it. And we also discussed about platform as a service. And I mentioned that in case of platform as a service, the cloud will provide you a platform for what? For development and deployment of software applications. Now, which particular application, it can vary. So whichever application that you want to develop or you want to build, then you can actually use platform as a service that will allow you to develop and build that application without installing IDE, without installing the compilers, without installing all of these things by yourself, all of this dependency by yourself. You just say, okay, I want this dependency, and then those dependencies will be provided to you in the platform as a service. And you don't care about the operating system. The only thing you want is develop your application and deploy them. So we do not worry about the underlying architecture. So that is what we call platform as a service. And I mentioned that there are some examples that we use in AWS and also in Microsoft Azure, where You just go, let's say, for example, you want to build a Node.js application and host it. You just go platform as a service, they give you, and then you can use it over there. So those were the platform as a service. And lastly, we also discussed about infrastructure as a service, which is a more technical part of cloud computing, because in case of infrastructure as a service, you have to build and design your own infrastructure. The cloud infrastructure, you have to build it, and you have to build it from the ground. Let's say, for example, you will choose your server, you will choose what operating system do you want, you will choose what is the storage that you need, so what is the network, what is the VPC. So all of these things will actually be designed by you, by you, the user. So the security, or also some of the security, you as the user will also be managing some of the security of those services. So that is infrastructure as a service in cloud computing. And then the last thing that we discussed was also the different deployment models. And I explained that there are four mainly. I'm not sure whether we went to the details of deployment modules, but basically there are four types of deployment modules, main types. We have what we call private cloud, we have public cloud, we have hybrid cloud, and then community cloud. So these are the four: public, private, community, and hybrid. And in case of public, what does that mean? It means that your cloud services are available for all users. Let's say, for example, if we host an EC2 in a public cloud, what does that mean? It means that that particular EC2 can be accessible by anybody. So if you are hosting an e-commerce website, if you are hosting something that the public can access, in that case, you can host it in a public cloud. And whenever it comes to the private cloud, in private cloud, what happens? It is limited to a single organization. If IoT wants to host something that will only be accessible, let's for example, by IoT employees, in that case, what does happen? You can host those type of things, or you can deploy them in what we call a private cloud, so that it will not be allowed for the public to have access to those cloud infrastructures. And then we discussed also about community cloud. And I mentioned that in case of community cloud, what does that mean? It means that multiple organizations come together and create an infrastructure where all the members of those organizations can access that cloud. So that is what we call community cloud. And an example, let's say, for example, if IoT and maybe BOET and Dhaka University and these different universities, if they are trying to collaborate on a particular research domain or something, in that case, they can create a community cloud whereby all of those people, all of the shareholders of these universities can access those particular cloud or resources. In that case, we will talk about it's a community cloud. And the last one that we also discussed was the hybrid. And hybrid just means that what hybrid cloud, which is the combination of at least two of those clouds. And why will you actually need this hybrid cloud? Let's say, for example, in the case of IoT, if you are building a system whereby one part of the system is very sensitive and the data has to be private and everything has to be properly secured, and then one part of the system has to be accessible by the public. In that case, you can deploy what we call a hybrid cloud, whereby everything that you think is very sensitive and very important and very confidential can be deployed in the private cloud. And then things that can be accessible by the public can be deployed in the public cloud. So the combination of these two is what we call hybrid cloud. So that's a brief generalization of what we did from the previous class. As I've said, I don't want this class to be too long because online classes are not the best personally when it comes to interaction or maybe making sure that the students and you are following on the same page. So I'll just discuss the generality of what we are going to be doing. And when we get to physical classes, then in that case, I'll come back to it and we'll go into the details of these topics. Now, for the next thing that we'll be talking about or discussing in this particular course is what we call the concepts and enabling technologies. Now, what does this actually mean and what is the purpose of this thing? We've discussed the characteristics of cloud computing. Now, what makes those characteristics possible inside the cloud? That is what we call enabling technologies. What are the technologies that allow the characteristics of cloud computing to be possible? So what are these different technologies that make cloud computing possible? Those are the things that we will be discussing. As I've said, I will not go into the details of any of these. I'll discuss in generality and I'll just end the class. And then hopefully maybe from tomorrow or whenever we start physical classes, then in that case, we'll go into the details of each and every one of one of these things. Now, the very first thing is virtualization. Now, without virtualization, we understand that not many things can be done in the cloud. Now, if we don't have virtualization, how will the cloud have to work? It means that if I say I need a server, then AWS has to provide me my own server. And then a particular user or you or anybody else requests for a server, then AWS has to provide what? The server for that particular user also. And then if I come and I say, okay, I need maybe any network card, then AWS has to provide those things physically. And that is impossible. You cannot scale with those type of implementation. So virtualization is one of the most important technologies in the cloud because it allows us to virtualize these resources and then provide the resources to the customer or the user. And in one server, you can have maybe 5 or 10 or however many users you actually need by using virtualization, rather than just making sure that each and every server is dedicated to one single user. Then in that case, it will be impossible to scale and it will be very, very expensive. So, and we'll go into virtualization and see the different types of virtualization and what are the things and how is virtualization implemented. We'll see what we call hypervisors. So whereby you create a particular environment where you can actually deploy virtualized resources. We'll discuss those. And then we'll also talk about load balancing, which is also something that makes cloud computing possible. And let's say, for example, when we talk about, let's say, availability and reliability, these type of things cannot be achieved without load balancing. And we'll discuss load balancing and see the techniques of load balancing, because load balancing, the concept is that what? We want to create a mechanism whereby this particular load balancer will actually distribute traffic through different servers. Let's assume that I'm trying to access a server, maybe for anything. It can be, let's say, a healthcare application. Now, if that healthcare is hosted in a single server, and then many users are trying to access that same application, what happens? The server will be overwhelmed. So it will be difficult now to serve all the users. So with load balancer, it will allow us to distribute traffic evenly. Let's say now you will replicate this particular healthcare application in 4 or 5 servers. And then it will distribute traffic evenly through these 4 or 5 servers so that we can have things like availability to make sure that each and every time you want to access this thing, you can access it. So things like load balancer. And also scalability and elasticity. We'll also discuss about these things and why they are needed and how they actually make cloud computing possible. We'll talk about the deployment and replication. What is the replication policy? So depending on the service that you are using in the cloud, that's what we call replication, whereby one of the policies of the cloud, I was even discussing this with you in class, is that what? Cloud has to make sure that if a single server crashes right now, no service should actually stop because one server has crashed. So that is one of the things that cloud computing is. And we were discussing, when you talk about the characteristics of cloud computing, availability, reliability. Now, if you want to make sure you have high availability and then everything is stored in one server, then you will not have high availability. Because as soon as there is a problem with that single server, you cannot access anything. So replication will allow us to actually replicate whatever we have in different servers in different locations. So it will try to replicate the same thing in different places so that even if one of them crashes, then in that case, the other one will still be able to work. And it will also make it faster so that, let's say, for example, if there's a data center in Asia, maybe in Europe and maybe North America or something, so it is easier for you to access a server that is closer to you. So replication will actually enable these things. I will talk about monitoring and MapReduce. As I've said, with MapReduce, we will not discuss too much into it right now. We'll discuss MapReduce when we talk about big data and big data analysis. Then we will see how the implementation of actually MapReduce is actually implemented in practice, in actual practicality. So, and then we'll discuss about some security things like identity and access manager, how the security of cloud computing is actually maintained, and we'll have this general discussion. But I don't want to go into the exact the details of this thing. As I've said, I don't want the class to be too long. And when we start with physical classes again, then we'll come and discuss these topics in details and go to the details of each and every one of these topics. Uh, I've uploaded a Google Sheet. I think I've mentioned to you in your Google Classroom. You have to fill that sheet by Friday. All of you has to be filled by Friday. You have to it's just very simple information, just your ID, your name, and email. So that is not a lot of information is needed, and so that I will use it to create a classroom in AWS where you'll be allowed to use AWS resources. Let's say, for example, EC2, you'll be allowed to launch different things. So you have to try to do that, because maybe Monday we'll start just demonstrating about how this different thing actually works. So please, you have to make sure you go to the link. Did I provide the link? I don't think the link is provided. Hello? Hello?
Sir, you made the post, but you didn't include the link to the Google Sheet.
Yes, I just realized it right now. Oh, and also, I don't even know if anybody was speaking or not, because my earphones were actually connected to my computer and I was just aside. So I was just speaking. I could not hear anything. It's just right now that I realized that my earphone was also connected. But as I've said, I've included the link. You'll go to the link and then you'll fill up the link by Friday latest. And then after that, I'll create the classroom and provide you. And you just go to AWS and then use that particular classroom. And please do not fill the same cell that somebody else is already filling. Try to make sure that if you realize somebody is already accessing a particular cell, do not access the same cell again. You can try to fill yours in a different cell, so that you don't override someone or whatever someone else has already filled. I would call the attendance right now. If there is no questions from any of you, I'll just call your ID, and that would be yes. Did somebody say something? Okay, I'll just call the attendance then, and then I'll just end the class. As I've said, tomorrow we are going to go into the details of these things and see how they actually enable cloud computing to make it possible. The online classes usually is less interactive, so that's why I do not want to go into the details of it, but just give you a general overview of the whole thing. So ID 102. ID 108. 108. ID 11.
Yes, sir.
ID 12.
Yes, sir.
Please, as soon as